Okay, so let's see a little demonstration of SQL injection in action. Here I have the login page for the purposely vulnerable web application that we built back in CIS 59. First, what I'm going to do is log in as the admin user. And right now the admin user's username is admin and the password is admin. So I'm just going to copy this. I'm going to paste it into each of these fields. Paste admin, paste admin. Okay, we're going to click the login button and it works. And you can see that the user is an admin user. See their role set to admin user. And this is basically all admin users get taken to the admin interface, and it prints out every row in the users table. The first row in the users table is the user record for the admin user. So you can see that their username is admin, their password is admin, their role is admin user. And we also have a user here called jhengels, the password secret. And so what I'm going to try to do is log out. I'm going to log in as jhengels, secret, log in. Okay, so it takes me to the regular user interface. That's because the jhengels user has the regular user role. This is all that regular users are allowed to do, change their password or log out. So let's see if we can test this form field to see if it's vulnerable to SQL injection. So what I'm going to do is actually take a look at the source code for now. And here's the function that actually handles updating the password in the database. It's called update password in DB. And right here, we send a SQL query to the database. Our SQL query is simply update users, that's the name of the table, set password, which is one of our columns, equal to whatever's in the password variable, where username, which is the name of another column, is equal to whatever's in the username variable. Now the username variable actually gets populated by way of something that's in the cookie. We don't have to worry about that for now. The important part to know is that this form field, whatever gets entered in this form field called password, is what gets put into the password variable when the form gets submitted. So when I click update, when I type something into this form field and click update, whatever gets typed into that field ends up in this variable. And so when we create this string, the $password here is going to get replaced with whatever the actual contents of that variable are. And so if I type ABC123, this will actually read update users set password equals ABC123, where username equals, and I'm logged in as jhengels, so it's going to say where username equals jhengels. So what I want to do is actually put in some text in that form field that changes the structure of the SQL query. And I've got a little cheat sheet sort of thing here. What I'm going to do is put in this text and see if I can affect a SQL injection vulnerability. So what this says is we're going to, well, I'll just do it and show you how it works because I've actually updated the code so it prints out the updated query. So I'm going to just copy this whole thing, including that trailing space, which I'll talk about in a moment, paste it into here and click update. It's going to tell us the query is update users set password equal to sunshine, where username is equal to admin. This ends the SQL statement, SQL query. This 2 dashes, to MySQL, that's a comment. Just the same way that we saw PHP used comments by way of either a # or 2 forward slashes. It does the same thing, right? When MySQL sees this double dash here, followed by a space, so double dash space, it treats that as a comment and ignores everything that comes after it. So what we've effectively done here is put this information into the form field. Oops. This into the form field and submitted the form. When we did that, this information from the form field got placed into the password variable, which got expanded right here into the query string. And essentially what it's done is it has altered the structure of the query. So the query basically is just this now, and everything that came after it gets ignored. So let's take a look at the actual query here. Let's see if we can get them to line up. So here's our query. It says update users set password, update users set password, equal to single quote, equal to single quote, whatever's in the password variable. Well, all of this was in the password variable, so it plugs that in. And then single quote, that's our single quote there, space where space, space where space, username equals, single quote, J Hengels, that got taken from the cookie, single quote, semicolon. So basically we just put in some data that totally changed the structure of the SQL query and then said, by the way, ignore the rest of the original SQL query. So let's see if it actually worked. So we'll go back, we'll click log out, and we will try to log back in as the admin user. Copy, admin, paste, paste. Now, if that SQL injection attack worked, our password will no longer be admin. Let's see. Our password is no longer admin. Didn't work. We couldn't log in. So presumably our SQL injection worked. Well, what did we actually try to set that password to? We tried to set it to sunshine. So let's try that. Admin sunshine. Log in. It works, and you can see that the admin user's password is now sunshine. So not only were we able to change the structure of the SQL query and make it do something other than what the programmer originally intended, you can see that there was no access control enforced. It allowed us to change someone else's password. That's because access controls are generally enforced by the PHP code, but this was a database query. PHP code, once it sends that query off to the database, it has no control over what's happening there. This is a change that actually happened inside of the database. So as a regular user, we were able to change the admin user's password, and now we know it and we can log in. So that's a basic example of how SQL injection works. There are a lot of variations to it. We'll see some of those as we get into CIS 57, but hopefully that illustrates the concept for now.